Welcome all. Now in this video I'm going to discuss this concept change of order of integration. Now what is the meaning of order of integration in the concept or in the problems of double integration? Suppose I have been given a problem double integration, and here I have been given the limit f1y is a function of y, here f2y, and here given c to d f of some function of xy dx dy. The meaning of order of integration is you are given two variable x and y, so you will be integrating with one of the variable at once and treat other variable as a fixed quantity or a constant quantity. Now question arises with respect to which variable you are going to integrate first, and that is always decided by these limits. So you will be doing the integration with respect to that variable first, whose limits will be this limits. So if this is the functions of y, definitely they are the limits of x variable. Is it clear? If this is the function of y, this is the limit of x variable, and definitely this will be the limit of y variable. That means the problem which is given to me, I will be first integrating with x and then I'll be integrating with y. That is the order of this integration. When I'm saying I'll be first integrating with x, that means my strip in the region in which I am doing this integration is horizontal, because this is the limit of this strip. Remember, into double integration, this is the integral which we do always on the strip. So I am doing the integration on the strip, and a strip is parallel to x-axis. That means it's a horizontal strip. So you will be integrating first with x, then with y. Whereas if I have been given the integral, this is f1x, this is f2x, and this is x is equal to a to x is equal to b, some function of xy dx dy. Here this is the limit of a strip, and if you look at the limit of a strip, they are function of x. So if they are function of x, they are the limits of y variable. So I'll be integrating first with y, then with x. So here order is first with y, then with x. Here the order is first with x, then with y. In this case, my strip is parallel to y-axis. That means here is a vertical strip, whereas here is a horizontal strip because it is parallel to x-axis. So here order is first with y, then with x. Here order is first with x, then with y. So if I have been given an integral, double integration, and some order is given to us to integrate like this, first with x then with y, and if I want to change its order, then I want to make it order first with y then with x. Means if I have been given a horizontal strip, I should take the vertical strip in that region. So that is the all concept of change of order of integration. If you are given a horizontal strip, take the vertical strip, order will automatically change. Or if you are given a vertical strip, you take horizontal strip, order will change. So change of order of integration means you first identify your reason on which you are doing the integration, and then if you are given a horizontal strip, you take vertical strip, or if you are given a vertical strip, take the horizontal strip to change the order of integration. Why we do this? There is many application of it, like sometimes it happen that by changing the order of integration, the integral which is given to us to solve becomes simpler. That is one important aspect or one important benefit of this method we are going to take. Now to explain this to all of you, I'm taking an example. The question is given to us 0 to 6, 2 minus x to 2 plus x, f of xy dx dy. This is the problem given to me to change the order. Now if you look at this limit is the limit of x variable. So definitely they are the limits of y. Means I have been given a vertical strip, and the strip start from the curve y is 2 minus x, which is a line, goes to y is 2 plus x. That is another line. And these are the limits of x. The strip between these two curves is moved from x is 0 to x is equal to 6. Okay, let's plot all of 4 of these. So y is 2 minus x. Y is 2 minus x, where it will cut the x-axis at 2 comma 0, and it will cut the y-axis at 0 comma 2. So if I connect these two, I'll be getting this line. And y is 2 plus x, where it will be cutting x-axis at minus 2 comma 0, y-axis at 0 comma 2. So this is y, this one is y is 2 minus x, and this one is y is 2 plus x. Okay, now x is equal to 0 is my y-axis, x is equal to 6, I'm taking it somewhere here, x is equal to 6. What is the coordinate of this point? X is 6. This point I'm achieving by the intersection of this line and this line. So x is equal to 6 if I'm putting here, I get y is minus 4. And if I'm trying to find out the coordinate of this point, x is 6 if I'm putting here, y is 8. Now I have been given a vertical strip which starts from here, goes to here, and that is moved from x is 0 to x is equal to 6. So by that way, this is my reason of integration on which this integral is given. Now to change the order, I have been given a vertical strip, I will take the horizontal strip. Now look at the part of my pen. This is my horizontal strip. From where it starts? It starts from this curve. It starts from this curve. And where it ends to this curve. So it is starting from here, ending to here. But this strip, when I'll try to move up to cover the region, till here it is okay. But above this, the one part, left part of the strip is switching the curve. Means its limit will be different after this, left part of the limit. Or I should say lower part of the limit. Okay, so my horizontal strip here is okay. After this line, above that, my horizontal strip will have a different limit. So if my strip is switching any of the curve, its limit will be different. If its limit will be different, then I have to write down a different integral for that part, wherever it will have a different limit. So I'm dividing this entire region in two parts, R1 and R2. Two regions. This is R1 region, this is R2 region. In R1 region, my strip limit will be something, in R2 region, something else. So when I'm changing the order of integral, now for R1, I'm writing the integral with the horizontal strip. So it starts from this curve. What is x on this curve? The equation of the curve is this. Using that equation, if I want to write x, it is 2 minus y. And this strip starts from that curve, end here. What is x on that curve? X is equal to 6. And that strip, this strip, from where to where you will move to cover the region? You will move from y is this point to y is this point. Remember, one basic concept is there in double integration, that all horizontal movement is left to right and all vertical movement is down to up, irrespective of the quadrant. You will be moving left to right if you are thinking horizontally, if you will be moving down to up if you are thinking vertically. So from here to here, so from y is equal to minus 4, that is the here, to y is equal to 2, that is on this line, y is 2. F of xy dx dy. Now for R2, your horizontal strip start from this curve. Start from this curve. And on this curve, this is the equation of that curve. This is the line. X is y minus 2. And goes to x is equal to this line, 6. And that we move from y is 2. What is y here? 2. Y is 2 to y is equal to this point. Y is 2 to y is equal to 8 f of xy dx dy. This is the integral for R1. This is the integral for R2 if I take horizontal strip. So on changing the order we get, for the reason R1, x is 2 minus y, 2x is equal to 6, y is minus 4, 2y is 2, f of xy dx dy, plus x is y minus 2, 2x is 6, y is 2, 2y is 8, f of xy dx dy. This is the answer. Many times a question come from the students that on changing the order they should write dx dy or dy dx according to the order. That is not creates any much impact, because the order is always decided by the limits, not by this dx dy writing. I should write dx dy or dy dx, doesn't make much difference, because this dx dy is the area of a small rectangular patch on the region of integration. And if I am writing the area of a rectangular patch, I write length into breadth or breadth into length, it doesn't make much difference. Thank you.